This podcast is brought to you by Infrastructure Masons, uniting builders for the digital future. Looking to turn your innovative idea into the next big thing in digital infrastructure? The iMasons Incubator is here to help you connect with industry leaders, spark awareness, and accelerate your path to success. If your concept can help drive a more sustainable digital future, we want to hear from you. Don't miss this chance to grow, give back, and shape the digital landscape. Email innovation@imasons.org today and find out how the iMasons Incubator can help bring your idea to the world.
Dive into the world of data center innovation with the iMasons podcast, discovering the people leading the industry revolution. My name is Romain Truncheon, and today I'm joined by Scott Sickmiller, CEO at Midas Immersion Cooling. Midas Immersion Cooling is the leading supplier of immersion cooling equipment solutions for data centers and ASIC mining. Scott has accepted to share his experience of what makes liquid cooling a suitable and sometimes superior solution for cooling. Let's get right into it. Well, Scott, thank you very much for sharing your time and experience today with us. Welcome to the podcast. I really hope that we're going to have a really interesting discussion today.
Thank you for having me, Romain. It's an exciting time to be in immersion. Densities continue to increase. Immersion's getting more and more popular. I greatly appreciate the opportunity to talk about it.
So, for the listeners that might not know you or might not know Midas, do you want to give us a brief introduction?
Absolutely. I'll start with my introduction. I've been CEO of Midas for about 3 years now. I come from a diverse manufacturing background, which really comes along with the growth of immersion. As immersion started taking off, Midas was building more and more and transitioned away from an R&D and IP company to a manufacturer. For Midas, we were actually the world's first commercialized data center here in Austin. We started in 2011 and with limited power and needed to capitalize all the power that we had to turn into revenue into the compute. And we did that through 2011, 2016. And then at 2016 started selling the solution that we had successfully used. Exited the data center world business, awful hard to compete with AWS in 2016, 2017, and have successfully deployed about 4,000 tanks to date.
That's an amazing accomplishment. But let's roll back a little bit. When you and I were preparing, you told me some fascinating facts about the fact that liquid cooling is not new at all. Can you take us through the history of liquid cooling, maybe like snapshots of the interesting points up to today?
Absolutely. We, as human beings, we have this natural aversion of electricity and fluid. But the history of the two go together almost from the industrialization of electricity. Back in 1887, the first fluid was patented for use in transformers. As we move and fast forward by the mid-1990 or 1968, 1900s, IBM had a patent for utilizing dielectric in computers. We fast forward a little bit more. By the time we get to 1994, the military is using immersion cooling on aircrafts. And then we fast forward even more into the early 21st century, where there are several major players with several patents out there utilizing dielectric immersion cooling to keep components cool. And the exciting thing about it is all of the major players just continue to advance and improve to provide a better solution for the end users. So it's two technologies, or a need and a technology that's converging at the right time.
So as with everything, as we get closer to understanding immersion, and that was literally my journey through this, as I discovered a lot of things, it gets more and more refined and complicated. There isn't just one version of immersion cooling, isn't it? there is refinement and differences in even in that sub-segment of cooling.
Absolutely, and all immersion works better than air. But if you want to understand what's best for you, you need to understand the options that are out there. So, immersion at its most basic level uses a natural convection. You put the heat source in the fluid, it heats up. We all know that heat rises, cool drops, and it naturally moves the fluid around the cooling. We kind of call it the ice cube because usually the bath you work to cool. So you'll put a liquid heat exchanger in the tank to keep that dielectric cool. And it's a very simplistic solution that works very well to a certain level of IT density. Then the next level of single phase non evaporating fluid is forced convection. And we kind of call that the jacuzzi. That's where most of the providers today have transitioned to, where we're utilizing a pump to push the fluid across the IT services. There is some natural convection occurring, but in our world, there's two variables that we control: flow and temperature. And by being able to control the flow with forced convection, we can get to a higher level of density. And then there's technology where the cooling is done by the evaporation of the dielectric. That's a dual phase uh, uh, immersion cooling technology, and it's been around for a very long time. The fluid has fluorinated properties that allow it to be stable but still uh, evaporate at a relatively low temperature. Interesting technology, but does have some environmental concerns. So that's not where most of the industry is focusing at today.
So when we immersions have got properties in itself that makes it sometime a better use case for cooling. Can you take me through by principle what immersion achieves when it's being deployed correctly?
So we can we can break it down just if we start looking at the server and then build it out from there. Um, and until recently, server densities have been relatively modest, 400 watts. But for an example, for this dialogue, I'll use a 1 kilowatt server as an example. And there are several out there. So it's no longer the unicorn. In fact, we're seeing densities much higher than a kilowatt server. The first element that immersion does for an individual, for a company, is it eliminates the power waste of the fans. So you look at a 1 kilowatt server. When you remove the fans, you usually are harvesting about 150 watts. So 15% savings immediately. We argue that we move the one in PUE, uh, and we effectively do. Immersion is the only technology that effectively, meaningfully moves the one in the PUE equation. But then when you go beyond that, if we look at a deployment that utilizes the same amount of compute, and we can model this for Saudi Arabia, Dallas, Texas, or London in the UK, uh, you're going to get much more compute with much less power. And where's that impact on the ROI? It's less USBs, it's less gensets. And then when you look at it on a CapEx basis, there's a significant amount of savings because you're doing the same amount of compute with 30-40% less power. So those are some of the commercial advantages of immersion. But ignoring those, if we just look at the operational advantages, and there are challenges that we can talk about later, but you look at most of the failure modes of IT. Uh, Fans obviously are our high failure point. Well, luckily we've just eliminated them. We see other needs for maintenance with thermal cycling. Things just walk when they get hot, cold, hot, cold. Both of those elements, removal of fans and a very thermally stable environment, are benefits of immersion. And then you look at anytime you want to tear into your rack on maintenance day, it's dirty, it's dusty, there's some oxidation. All of that is again eliminated when it's immersed in a bath. Uh, it is a very thermally stable, very clean, and for some clients where noise is important, a very quiet environment. So all of those are benefits of having an immersion cooling facility. But at the end of the day, it really comes down to power savings.
there is a lot of power savings just simply by moving to immersions, especially the one in the PUE is the one that gets reduced. But one of the interesting things you broke down for me, and I'd love to do that on the podcast, is if you do this at scale, the savings are significant, aren't they?
It really is tremendous. Obviously, being stationed in the states, we watch what the data centers world is doing here in the United States, and recently, many hyperscalers have announced pretty aggressive nuclear targets to bring on 5 gigawatts of compute power by 2030. That prompted us to dig a little bit deeper and do some work. When you look at the Uptime Institute, they say that the average PUE for data centers are 1.55. I would like to believe that majority of data centers are maturing. You see some of the hyperscalers that range from a 1.15 to a 1.35. So let's just say Uptime Institute hyperscalers, the national average for the United States is a 1.4 PUE. What's that meaning is about 400 watts of energy is used to cool every 1 kilowatt of compute. You look at the billions of dollars that are being invested to bring 5 gigawatts onto the national grid here in the States by 2030. And you look at that zero point 0.4 savings that's a potential on the PUE on immersion, just by changing the existing infrastructure from air cooled to immersion. If all things being equal, we simplify this, we could bring 8 gigawatts of power savings to the United States data center grid immediately within reason. We can talk about scaling up at some later time, but the math behind it states that just one provider of the majors could get that accomplished long before 2030. So for less money and a more environmentally acceptable solution, we could bring more savings to the power grid than what the investment in nuclear is doing for those 5 gigawatts.
That's definitely an interesting things to put in comparison. Nuclear and immersion cooling. I don't think anybody else done that before. But what was more fascinating to me is that one of the questions I asked you part of the preparation was, and I was under the impression that immersion cooling actually would cost more to deploy than any other technologies. We're talking about reinforced concrete, large tanks, loads of oil, and loads of pipe work and so on. And your reaction to this was fascinating to me because you said, no, actually it's quite the opposite. The TCO going to immersion cooling straight away to immersion cooling is actually far cheaper than going air cooled with because the number of equipment gets reduced. Can you break that down for us here and tell us like where the logic applies in this?
Absolutely. And I mentioned it a little bit earlier, but if we look for just the amount of compute, ignoring the overall data center consumption, just the amount of compute and the peripherals to keep that compute rolling, you are the savings. There are no cracks. There are the day-to-day energy savings. On the bright side of needing less energy day to day to complete the same compute, you have to have less of the redundant elements in play to protect that compute, less gensets, less US uninterrupted power supplies. So there's a great deal that you don't have to purchase, even though you do need to purchase the immersion cooling. To keep a chip cooler with air, you take a much lower approach angle because air is such an inefficient heat remover. So you need to bring that air temperature much farther down. In fluid being a much greater heat dissipator, you can have that approach angle leading up to that chip much higher. So for most deployments, you can eliminate the need for a chiller. You're able to use either a regular dry cooler or potentially an adiabatic evaporative type cooler. So that's another piece of CapEx not needed. For a greenfield site, you're going to build a designated immersion cooled data site. The ROI is instantaneous. It costs less to build per megawatt than it does a comparative air cooled or direct liquid to chip site. For a refit, unfortunately, the cracks are there, the chillers are there, the infrastructure is there. But then we start looking at the total cost of ownership, bringing in that ROI, and depending on power costs, and that's where in the states we're a little spoiled. Here in Austin, 12, 13 cents a kilowatt. We have customers that are in the 2 to 3 cents per kilowatt because they consume so much. So it takes a little bit longer for those savings to be there, but it's still 40% of that is still 40% of that. When you look at where you're sitting at converting over to the U.S. dollar, 26 to 35 cents per kilowatt, those savings start adding up tremendously because the infrastructure costs all the same per piece. Uh, anyway, as we look at retrofits, most ROIs are within 12 months. And when you look at a 3-year projected savings, the savings are substantial. Again, it depends on the base PUE that we're replacing and the area and the local power cost. But it's tremendous. And then outside of the commercial elements, we have clients that have only so much power, very similar to what Midas started at as a data center. So if they have 10 megawatts of power and they're using 4 megawatts to cool and they're power locked, they're either going to have to change technologies or continue only getting paid for 6 megawatt of compute. We've had clients been able to, in a 10 megawatt site, be able to bring up another 2 to 3 megawatt, maybe a little over 9 megawatt with 10 megawatt complete coming into site, and still increase the revenue. So those are some opportunity costs that's awful hard to capture on a pure total cost of ownership calculator. But again, it's all down to math. No objectivity to it, or no subjectivity. It's all objective data that we're able to compute and show the savings.
So we're talking about, and we have talked on this podcast about heat reuse, about the fact that those computers actually reject a large amount of heat, and that it could be made useful for other kind of industries. We've also already mentioned that immersion cooling is far more efficient at bringing that heat out of the facility to be reused somewhere else. Have you seen any practical use case already deployed, using your tanks to make it happen?
Yeah, absolutely, and this is a part that's kind of near and dear to my heart. So apologize if I go a little long on this front, but it seems very wasteful if we can just sit back and think that we're spending the 25 30 cents per kilowatt getting an output, an IT computation, and then just moving on. But there is there is almost no better device for transferring energy to heat than a computer. So in an air cooled environment, we're paying so much money to keep it cool and move it in, and then paying money to remove that heat. In an immersion environment, the dielectric does such a good job of capturing that heat, and it's relatively stable because it's much more thermally dense. So at that point, we can move it. You talked about actual applications. So we have tanks deployed that are heating pools at hotels. It's actually a relatively new pilot here in the States that could completely revolutionize the amount of data being wasted just for pool heating. You look at a typical pool in a hotel, spending 18 kilowatts to heat that pool is not uncommon, and then they just throw it away. If they are able to instead sell the data that consume that 18 kilowatts and then use the residual, the output of that to heat the pool, it becomes a win-win for multiple people, including the environment, right? Outside of that, greenhouses and data centers are a natural fit that we just don't see them as much as we should. I'm going to go quite a bit north because we're here in Texas, so it's very little to do here in Texas with the heat reuse. But you move up to Minnesota, you move up to Canada, or we move over to the pond to where you're at in the UK, that heat gets to be very beneficial. Let's talk an opportunity, a project in Norway. This happened to be an ASIC mining application, but 1 megawatt of heat rejection in that environment heats about 1 acre of greenhouse tomatoes. The great thing about that client is not only did they get the Bitcoin, they're selling the tomatoes for €2 or €3 a piece in the wintertime. Um, we move farther north here in the States. I already mentioned Canada, where weed is legal. Believe it or not, growing weed and growing tomatoes are a very similar environment and about the same type of scenario. 1 megawatt of heat rejection, about 1 acre of greenhouse environment. Then let's bring it a little bit closer to home. We have a client in Minnesota that's using the water to keep the heated water from the liquid heat exchanger to keep his driveway clear in the wintertime. We have projects where you're at for district heating. Let's move that heat going into district heating. It's still relatively low grade heat at 45 or 50 degrees C, but it gets us closer to that 95 degrees C where we need. And it's already energy being spent. Uh, we can do more exciting things with heat pumps or other technologies to store that heat. But it's an interesting technology and it opens up opportunities that people don't think about. And as we look at the circular economy and we look at the maximization of the energy that we have available without spending billions on opening up 3 Mile Island nuclear reactor in New York, we can look at how do we align the energy consumptions. As mentioned yesterday while we were talking, Romaine, it'd be great to see a large data center next to a very large plastic injection manufacturer because the heat coming off of a data center, immersion data center, is perfect for preheating plastic injection molds. I would love Red Bull to call me and say, hey, I'd love to have the output of our data to preheat our carbon fiber autoclaves. Is that going to happen? Don't know, but I'm still waiting for the call. So call me up. So anyway, that's where we're at. It's interesting that the solutions are endless as long as we have an open mind on what we want to do with it.
And it's not just about data centers at scale. It also opens up opportunities to actually do it on a much, much smaller footprint, a much more divided footprint, I would say, or distributed, right? You don't really need to have, once you've got a tank, you don't really need to have 200 of them lying next to each other, don't you?
No, not absolutely not. I'd mentioned the potential at heating hotels. You know, there are plenty of hotels. You look at the major chains; they have 8, 9, 10,000 hotels in a geographic area such as the United States, and each one of those could be a mini 15 to 18 kilowatt um, data center. Right? Any place that is using energy to heat a reasonable amount of energy, or anybody that is just tossing that energy away doing compute today. There are enough of these opportunities where the marriage makes sense. We just have to think outside the box to get there.
So we've been talking about the greats and the goods. Let's go a little bit the other way, right? We hope that with all the benefits, like the take up would be far more salient than what it's been so far. Can you take us through like what's stopping people today from actually embracing immersion cooling?
Yeah. The challenges are real, but the positive in our world is that they're getting smaller. But the number one challenge is fear. So we talked about the fact that electricity and fluid in our mind does not come together, even though they've been married together almost since the industrial start of electricity. But the fact that it's different, it's a horizontal platform versus a vertical platform. Uh, the You interact with it differently. There are different variables. A 42U rack all looks the same no matter who's manufacturing. Today, with the major suppliers of immersion, they're all looking a little bit different. Uh, so that the difference, the fear, those are the two primary obstacles that I face and all of the immersion companies face to get in the door. Once you get in the door, then you start understanding a little bit more of some of the challenges. And quite truthfully, it's equipment. Today, you can get a Dell server, but you go through a third party that they've partnered with. There are a great deal of tier two servers. It's a bad term, but servers that sell, manufacturers that sell less into the industry that have embraced immersion, that's immersion ready. But you don't walk up to an HPE, a Dell, or Lenovo and see an open SKU for that immersion technology. And because there's not an open SKU, warranties become a challenge. Now we have solved that warranty problem using third parties, but there's a cost to that. It just doesn't happen to be a cost to that is incurred by Dell or Lenovo. It's a cost that we incur to the customer as we have that solution. But the IT acceptance has been a challenge, and we'll talk a little bit after some of the other challenges of why I kind of even support that. But it goes to the work that the industry is doing to combat some of those fears. Um, the As a data center operator for a long time and having helped deploy over 4,000 tanks, it takes a different tool set and mindset to be successful in an immersion data hall. Again, you just look at the form factor. We're used to pulling items out. We get service carts to support it. We're able to work on it. We put it back. Uh, People don't think about using the compressed air and cleaning off the dust and dirt. It's just part of the process. In an immersion environment, it's oily. I can't deny it. That's how we keep it cool. So we use a hoist to lift it up, have a drip tray underneath of it, move it to a work environment, and with the proper tool that has it covered or has the drips contained from the beginning, it's literally you lift it up, you swivel it, you lay it down on the service cart, and then you have an oily environment. It's an oily environment versus a dusty environment, but it's still a something that needs to be addressed. Um,
Yep.
so you glove up in about 10 seconds, 10 to 30 seconds, the majority of the oil is stripped off. And then you work on it. And it's a training element. Um, we have several videos out there, and I know other immersion companies do as well, of showing maintenance work in that immersion environment. It's not difficult, it's just different. So those training, having the tools, training the staff correctly, and just breaking over that fear are some of the largest difficulties that we've got. Um, you know, I get in front of potential clients every day, and they're okay with the immersion. They're okay with the solution brought in on the IT, but the oil just terrifies them. And having been involved with lubricants and dielectrics for a lot of my career, that always catches me a little off guard. Well, it's about the oil that's scary. Well, how do I get rid of it? Why do you need to get rid of it? We think of oil, we think of the changing the car oil every 6 months, and dielectric is completely different than motor oil. It's a low viscosity, highly synthesized hydrocarbon for most of it. There are different flavors out there, but the environment that it lives in is much different than most environments that we think of lubricants or oils being in. There's no shear. There's relatively low heat. Shear is just stress, friction stress. It just wants to. It's a very happy environment for the IT and for the cooling oil. We have a micro data center at our offices here in Austin, and that oil's been in place for 12 years. We test it, but has not needed changed. But for folks that have that fear, all of the oil majors now offer dielectrics, and there are many specialty dielectrics out there as well. All of these companies offer complete cradle to grave solutions. So not only are they there to sell it to you, they help support on the delivery installation, and they have a program for testing. And ultimately, if and when it needs to be changed out, or the facility's closing down, it needs to be removed. They also have programs that have a second life for that oil. So in 6, 9, 12 years, when that oil does get removed, it doesn't go to a recycler per se and gets dumped, drained, burnt, however it gets eliminated. It has a second life, a second use in life. Again, we are completely fluid agnostic, so I can talk about it, not pushing the fluid. But I can tell you, as I look at scope 2, scope 3, look at carbon impact, uh, the arguments that I face daily on dielectric, I'm usually able to put a hole in pretty quickly, because on the fear factor, the oil is one of the lowest. but it's always often ones that we have to address, the quickest. Some of the challenges, or the last challenge I'll talk about at length, comes down to people go, well, it's a new technology. Am I going to have to change it in a year or two? No, immersion is extremely future-proof, much more future-proof than the solutions today. We it wasn't that long ago where we were all talking about the mythical 100 watts per square centimeters. That's being left in the rearview mirror. I mentioned a 1U server, or a 1 kilowatt server. No longer being a unicorn. Quite truthfully, there's servers that are much, much warmer than that. And way at the beginning of our talk, Romain, I talked about some of the variables. We can control flow and we can control temperature. When we look at those controls and we look at the computational fluid dynamics, how the fluid moves around the components, we're early days on the capacity of immersion. Most immersion systems today are between 2 and 3, potentially 4 kilowatts a U of heat rejection capability, and we're capable of going much higher than that. So if you look at, I'll break it to a 42U thought process, even though our tanks are 50U. But you look at a 42U, achieving 250, 300 kilowatts of heat rejection relatively simply is not very difficult. When we look at other technologies and what's required to get even remotely close to that, they're basically tapped out. And I can say that because we have physics in our favor. So I'll just compare it quickly to direct liquid to chip. Direct liquid to chip has the same variables, the amount of flow and temperature, but they have the constraint of how large and how many capillaries they can bring to the heat generation service. And there is a limit to that. So when the capillaries get so large, and you can do some fancy stuff on the cold plate, but ultimately it becomes a volume and temperature deal. And it will cap out. And at that point, the only variable that you have is to bring the temperature down. Well, you bring the temperature of the coolant down enough, then you've lost your PUE advantage because now you're chilling the water. You're doing everything to cool the water that you had been doing to cool the data center. Where on a single phase immersion cooling technology with forced convection, which almost all of us are doing now of the providers, we still have room to play on the volume, leaving the temperature being reasonable, 25, 26, 27 degrees C incoming temperature. And I'll use an example. Now I'll get a little specific to my technology because I know it best. Today at 150 kilowatt of heat rejection, we're moving that fluid less than 10 inches per minute. So you think of a 4-foot tall tank, it's a little less than that. It's taken 4 minutes for that fluid to funnel through. We can substantially increase that and not have it be a complete bubble mess on the top of the tank. As we increase, computational fluid dynamics gets to be very interesting. We go from linear to turbulent flow. Then we have to work more closely for having the right heat sink or with the IT manufacturers to ensure the form factor allows the flow to go where it belongs. But at the same time, it's a variable that's controlled, and we're still early days into it. So that's why I say oftentimes people go, I don't want to change. I don't want to put the investment, put the oil, put the tank in 2 years, have it be obsolete. It's not going to be obsolete, not like the technology that you're deploying today. So those are the challenges. I don't know if there are any follow-up questions of the challenges before we go about what's being incurred to get those challenges behind us.
Yeah, it's thanks for taking us through this, and I think it would be very easy to really dismiss, all the changes that are coming up, as in let's continue on the same trajectory. I'm really glad to see you really at the forefront and beating the drum to showcase what liquid cooling can do. If I was an IT manager and I was tasked to actually deploy something or a micro data center somewhere, where do I start? Because I can go buy my IT equipment, I can go buy a tank, I can go buy those things, but in reality, where do I go? Where do I start? What's the first steps? Is there anybody else there that is working on those integrations, working on actually solutionizing the whole liquid cooling, the whole immersion cooling market?
Yeah, absolutely. There's a lot of work being done by, I'll call them independent agencies. And that's, if you have a lot of questions, those are places to start. So, Open Compute Project is doing a tremendous job. Throw a shout out to Rolf Brink, who was a founder of one of the immersion cooling companies, but now is working almost completely with just OCP, doing a great job leading the immersion push for standardization and reducing the variables that the IT OEMs have to manage to get us into a place to where we can have warranties, have a little more standardization, have immersion look, taste, and feel the same regardless of the provider. Within the industries, there are coalitions, frenemies, as we all get together and pull the immersion cooling companies and pull the rope the same direction, because ultimately a rising tide raises all boats. So, regardless of who is the solutions provider, what's good for immersion is good for immersion. Um, I can't say enough for the work that's being done for the infrastructure around an immersion data hall, whether it is non-wicking, non-hardening power cables. There are some vendors out there that are tremendous that have taken the bull by the horns and made these solutions. Early days of our data hall, we couldn't use multi-mode fiber optics. The refraction of the dielectric only allowed us to use single mode. Those solutions have been fixed. So the overall environment of immersion is pushing it forward because I think everybody is understanding that the densities are getting to the point where uh, immersion of one shape or form is going to be needed. So outside of that, we have a lot of, as I mentioned earlier, we call them tier twos. It's probably derogatory. I apologize to you all now. But we use a lot of vendors that aren't the major name brands, but they understand that immersion is their way to the top. So they're making immersion born, immersion ready servers, and it's literally plug and play. I mentioned that we have a small data hall here in the office. I received a server from one of those organizations, and literally from deboxing to dunking, powering up, and loading an application, it was less than 30 minutes. So all of that is really helping the immersion, people get ready for immersion.
Mm.
A specific answer to your question is every immersion cooling provider out there has the expertise. We call them solution architects. The solution architects to help a company wanting to get into immersion. What does the infrastructure looks like? What does it cost? What do I need to do? These are what I need to look out for. So any immersion provider can educate and guide. Now, obviously, at that point, we're all trying to sell our tanks, but regardless of who the immersion provider is, the answers are all extremely similar because almost everybody is using the same type of dielectric, uh, force convection, and the same physics. So that's the similarity among us all. One of the real recent changes, I say recent, the last 12 to 18 months, and I've mentioned the dielectric and how the oil has always been something I have to address on the risk side. Almost every large oil provider has now stepped up their game into support of the data centers and immersion. So you could either go directly to immersion provider, or the oil majors all have very good resources as well. So there are avenues to educate and to evaluate. And the great thing for the data center operator is they're no longer stuck to only one solution. They can evaluate. They can go with their name brand servers. There are solutions. Every major immersion provider can help with those solutions. You're not stuck with just one type of oil. You can go with oil major. You can go with 100% renewable oil from a non-oil major provider. There are different solutions, and all of the peripheral issues that people have had to fight through in the past, us included as a data center, have been solved. So it's easier today. But ultimately, go to OCP, go to Data Center World London, DC, um, wherever the large data center exhibit, and come talk to one of the providers. That Oftentimes we have examples, small solutions where you can actually see electronics in oil. We can talk about the technology, and we can talk about how it becomes real. The great thing is it's no longer renders on a website. All of the service providers have deployed real volumes at scale and are able to talk about what it requires. And that's a difference than where it was just a few years ago.
Yeah, that's fantastic. Thank you very much so much for taking us through all those details. Before we part ways, what I'd like to do is to point out listeners to your website if they want to learn more about the technologies that you put together. So Midas Immersion.com, Midas being MIDAS, Immersion.com. It's been great to learn more about it, and to be fair, I've been quite surprised about some of the answers a few times, especially with the total cost of ownership. I've always thought and was told a few times that it would be more expensive, so I'm glad to have been proven wrong on that one. If you're already an iMasons member, for our listeners, we'll be continuing all the discussions on the internal platforms, and that would be at imasons.mobilize.io. You can also reach out to the iMasons group directly on LinkedIn. There is a iMasons community group. But until then, Scott, thank you very much for taking the time today. You've taken the time to answer my questions and generally providing very interesting answers to them. On that note, thank you very much and see you next time.
Thank you, Romain. Bye-bye.
Bye.
1, 2, 3, 4.
Infrastructure Masons is a global, non-profit, professional association of individuals connected and empowered to build a greater digital future for all. If you too want access to networking events, forums, and summits that foster innovation and influence, register now and join the other 6,000 committed participants at immersons.org/membership application.